The reasoning for fireproofing the steel supports for the concrete encased primary lines is sound and aligns with the intent of the NEC requirements. Article 300.5d of the National Electrical Code requires that service conductors from a utility transformer to an isolating switch be enclosed in a raceway that is concrete encased in a material approved for the purpose, or buried underground. NEC Table 300.5 provides prescriptive methods for the installation of concrete encased raceways, but does not specifically address the fireproofing of supports. The encasement of the primary lines in concrete is intended to provide protection from fire and other hazards. However, if the supports for the raceway are not also fireproof, they could become a weak point in the system, potentially allowing fire to damage the raceway and the conductors within. The primary feeder cannot be de-energized from the service disconnect switches within the building. Therefore, it is essential that the entire system, including supports, be adequately protected against fire. It is recommended to fireproof the steel supports for the concrete encased primary lines using spray-on fireproofing materials. Ensure that the fireproofing meets the requirements of the local building code and applicable fire safety standards. Coordinate with the architect and structural engineer to ensure that the fireproofing does not adversely affect the structural integrity of the building. By following these recommendations, you can help ensure the safety of the building occupants and firefighters in the event of a fire. The National Electrical Code, or NEC, establishes minimum safety standards for electrical installations. These standards are designed to protect people and property from electrical hazards. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. Article 300 covers general wiring methods and materials. Section 300.5 specifically addresses underground installations. This section outlines the requirements for burying electrical conductors and raceways, including minimum burial depths, protection from damage, and proper backfilling. Table 300.5 provides specific requirements for concrete encased raceways, including the minimum thickness of the concrete encasement and the type of raceway that can be used. The intent of these requirements is to provide a robust and fire-resistant enclosure for primary service conductors. Concrete provides excellent fire protection, and the encasement helps to prevent damage to the conductors from physical impact and other hazards. However, the concrete encasement alone may not be sufficient to provide adequate fire protection if the steel supports for the raceway are not also fireproofed. Steel loses strength when exposed to high temperatures, and if the supports fail, the raceway could collapse, potentially exposing the conductors to fire and causing a short circuit or other electrical fault. Furthermore, the building's fire protection systems are designed with the assumption that the primary electrical feed will remain functional during a fire. Fireproofing the steel supports maintains the integrity of this critical electrical pathway. Several types of fireproofing materials are available, including spray-on fireproofing, intumescent coatings, and concrete encasement. Spray-on fireproofing is a commonly used material that is applied directly to the steel surface. It is relatively inexpensive and easy to apply, but it can be damaged by impact and abrasion. Intumescent coatings are thin film coatings that expand when exposed to heat, forming a char layer that protects the steel from fire. They are more expensive than spray-on fireproofing, but they are more durable and aesthetically pleasing. Concrete encasement is the most robust fireproofing method, but it is also the most expensive and time-consuming to install. When selecting a fireproofing material, it is important to consider the specific requirements of the application, including the fire resistance rating, the environmental conditions, and the cost. It is also important to ensure that the fireproofing material is compatible with the steel and the concrete. The local building code and applicable fire safety standards will specify the required fire resistance rating for the steel supports. Fire resistance rating is the amount of time that the steel can withstand exposure to fire without losing its structural integrity. The fire resistance rating is typically expressed in IRs, such as 1 IR, 2 IRs, or 3 IRs. The selection of an appropriate fireproofing material must meet or exceed the requirements. The architect and structural engineer should be involved in the selection process to ensure that the fireproofing material is compatible with the building's design and that it does not adversely affect the structural integrity of the building. Coordination is important because the added weight and thickness of the fireproofing can affect the load-bearing capacity of the steel supports. The installation of fireproofing should be performed by qualified professionals who are experienced in applying the material and who understand the applicable building codes and standards. Proper installation is essential to ensure that the fireproofing provides the required level of fire protection. Quality control inspections should be performed during and after installation to verify that the fireproofing has been properly applied and that it meets the specified requirements. These inspections may include visual inspections, thickness measurements, and adhesion tests. In summary, fireproofing the steel supports for concrete encased primary lines is a critical safety measure that helps to protect building occupants and firefighters in the event of a fire. By following the recommendations outlined above, you can ensure that the entire system is adequately protected against fire and that it meets the requirements of the local building code and applicable fire safety standards. Remember the key points. Firstly, the NEC requires concrete encasement for primary service conductors for fire protection. Secondly, unprotected steel supports can compromise the integrity of the concrete encasement. Thirdly, fireproofing the steel supports ensures the structural stability of the system during a fire. Fourthly, coordinate with architects and engineers to select appropriate fireproofing materials and ensure proper installation. Fifthly, comply with local building codes and fire safety standards. By addressing these points, you contribute to the overall safety and resilience of the high-rise building's electrical infrastructure. It is crucial to meticulously document all decisions, materials used, and installation procedures. This documentation serves as a valuable record for future inspections, maintenance, and potential modifications. Maintaining accurate records demonstrates a commitment to safety and code compliance. Consider implementing a regular inspection schedule for the fireproof steel supports. These inspections can help identify any signs of damage, degradation, or improper installation. Early detection of problems allows for timely repairs and prevents more significant issues from developing. As technology advances, new fireproofing materials and methods may emerge. Staying informed about the latest innovations in fire protection can help you optimize the performance and longevity of your fireproofing system. Consult with fire protection engineers and material suppliers to explore potential improvements. In addition to fireproofing, consider other fire safety measures to enhance the overall protection of the electrical system. These measures may include installing fire detection and suppression systems, providing adequate ventilation, and implementing fire safety training for building personnel. The fireproofing system should be integrated with the building's overall fire safety plan. Regularly review and update the fire safety plan to ensure that it remains effective and reflects any changes in the building's occupancy, layout, or electrical system. Communication and collaboration between various stakeholders, including architects, engineers, contractors, and building owners, are essential for successful fire protection. Establish clear lines of communication and encourage open dialogue to address any concerns or questions. Prioritizing fire safety not only protects lives and property, but also minimizes potential disruptions to business operations and reduces liability risks. A proactive approach to fire protection demonstrates a commitment to responsible building management. When choosing spray-on fireproofing materials, several factors should be considered. Firstly, the material's fire resistance rating. Secondly, its durability and resistance to environmental factors. Thirdly, its ease of application and maintenance. Fourthly, its cost-effectiveness. Fifthly, its compliance with relevant standards. Proper surface preparation is crucial for ensuring the adhesion of spray-on fireproofing materials. The steel surface should be clean, dry, and free from rust, grease, and other contaminants. Priming the steel surface before applying the fireproofing material can enhance adhesion and improve the overall performance of the system. Apply the fireproofing material in accordance with the manufacturer's instructions. Pay close attention to the recommended thickness, application technique, and curing time. Avoid applying the material in adverse weather conditions such as high winds, rain, or extreme temperatures. Inspect the applied fireproofing material for any defects such as cracks, voids, or delamination. Repair any defects promptly to prevent them from compromising the fire protection performance. Document the entire fireproofing process, including the materials used, the application date, the weather conditions, and any inspections or repairs performed. This documentation will be valuable for future reference and can be used to demonstrate compliance with building codes and standards. Regularly inspect the fireproof steel supports for any signs of damage or deterioration. Look for cracks, chips, or other signs of wear and tear. If any damage is detected, repair it promptly to maintain the fire protection performance. Keep the fireproof steel supports free from obstructions. Do not store materials or equipment near the supports that could damage the fireproofing or impede access for inspection and maintenance. If the building undergoes any renovations or modifications, ensure that the fireproofing system is not damaged or compromised. If necessary, reapply the fireproofing material to any areas that have been affected by the renovations. Train building personnel on the importance of fire safety and the proper procedures for responding to a fire. Ensure that they are familiar with the location of fire extinguishers, fire alarms, and other fire safety equipment. Conduct regular fire drills to practice evacuation procedures and ensure that building occupants know how to respond in the event of a fire. Consider installing a fire sprinkler system to provide additional fire protection. Fire sprinklers can quickly suppress a fire and prevent it from spreading, reducing the risk of property damage and injuries. A fire alarm system can provide early warning of a fire, giving building occupants more time to evacuate. Ensure that the fire alarm system is properly maintained and tested regularly. Develop a comprehensive fire safety plan that outlines the procedures for preventing fires, responding to fires, and evacuating the building. Review and update the fire safety plan regularly to ensure that it remains effective. Involve all stakeholders in the fire safety planning process, including building owners, managers, tenants, and fire officials. This collaborative approach will help to ensure that the fire safety plan is comprehensive and effective. The structural engineer is responsible for ensuring that the building's structure can withstand the loads imposed by the fireproofing materials. They will also ensure that the fireproofing materials do not adversely affect the structural integrity of the building. The architect is responsible for ensuring that the fireproofing system is aesthetically pleasing and that it does not clash with the building's overall design. They will also ensure that the fireproofing system meets the requirements of the local building code and applicable fire safety standards. The contractor is responsible for installing the fireproofing system in accordance with the manufacturer's instructions and the approved drawings. They will also ensure that the fireproofing system is properly inspected and tested. The building owner is responsible for maintaining the fireproofing system and ensuring that it is in good working order. They will also ensure that the building's occupants are aware of the fire safety procedures.